Let's continue with section 1.5 and do some more examples. If f of x equals to negative 2 radical x minus 4 over x to the sixth, find f prime of x. Now remember, the first rule is we need to write each variable using only rational exponents. So square root of x, this is like x to the first power, and you have a square root, so it's x to the 1/2. And then the x to the sixth goes to the numerator, and this becomes x to the negative 4, x to the negative sixth, because all variables have to be written on the numerator. Now, f prime of x, we take the 1/2 and we multiply it with the negative 2. So negative 2 times 1/2, that's going to be negative 1. And then we take x to the 1/2 and subtract 1 from it. Oops. With the next one, we take negative 6 multiplied by negative 4. This gives us a positive 24. We have a negative times a negative. And then we take negative 6, the original exponent, subtract 1 from it. On the side here, let's do 1/2 minus 1. 1 is same thing as 2 over 2. So this gives us negative 1/2. So f prime of x is going to equal to negative 1 x to the negative 1/2 plus 24 x to the negative 7th. Now we got x to the negative 1/2, which moves to the denominator, and the exponent becomes positive. So we got f prime of x equals to negative 1 over x to the 1/2. Same thing with x to the negative 7th. It's a negative exponent, so it moves to the denominator, becomes positive, since our final answer can only be written using positive exponents. Okay, so there we have it. That's our answer. Next, before we find the derivative, there's a property from back in the day that says that if you have multiple terms and they're being divided by a monomial, which means it's only one term, then we can write this as a over d plus b over d plus c over d. It's a quick recap. So first we're going to rewrite f of x as 36x to the 5th over 9x squared minus 18x cubed over 9x squared plus 45 over 9x squared. Okay, if I keep simplifying this, 36 divided by 9 is 4, and x to the 5th over x squared is going to be x to the 3rd. 18 divided by 9 is 2, x cubed over x squared is x. 45 divided by 9 is 5, and remember the x squared, we have to write this on the numerator, so this becomes 5x to the negative 2nd. Now let's take the derivative of this. So we got 3 times 4, which is 12, and we subtract 1 from the exponent. This gives us 12x to the 2nd power. There's an exponent of 1 here, so if I multiply 1 times 2, this gives me negative 2, and we got 1 minus 1, which is x to the 0. Lastly, we got negative 2 times 5, which is negative 10, and if I subtract 1, this gives me a negative 3. Okay, so f prime of x, this equals to 12x to the 2nd power. Recall the property that anything to the 0 power always equals to 1. So negative 2 times 1, this will just give you a negative 2. Remember, x to the 0, this equals to 1. So negative 2 times 1 is going to be negative 2. And then we can't have a negative exponent, so we move it to the denominator, and our final answer is going to become this. Next example, find all values of x where the graph of f of x equals 2x cubed minus 45x squared plus 300x minus 3 has a horizontal tangent line. Now, what does that mean, a horizontal tangent line? So let's say we have a graph like this. A horizontal line has a slope of 0. So for us to have a horizontal tangent line, there's going to be some point, and we got the tangent line. And if the tangent line is horizontal, then the slope is equal to 0. Now, do we remember what is the slope of the tangent line equal to? hopefully by now, since I've said it a million times, the slope of the tangent line is just equal to the derivative, f prime of x. So basically, we want to figure out where is f prime of x equal to 0. That's the question. So once again, let me restate that. We want to find out where does this graph have a horizontal tangent line. Now, first of all, tangent line refers to the slope of the tangent line refers to the derivative. And for a tangent line to be horizontal, its slope has to be 0 because all horizontal lines have a slope of 0. So anytime we want to find where we have a horizontal tangent line, we set f prime of x equal to 0 and solve for x. Okay, so our function is this. We got 2x to the third power minus 45x squared plus 300x minus 3. First, let's take f prime of x. So because remember, f prime of x, this will give us the slope of the tangent line. And that's what we're looking for, tangent line, slope of the tangent line. So if I multiply 3 times 2, this gives me a 6x to the second power. I subtract 1. If I multiply 2 times 45, this gives me a negative 90x. I subtract 1. This is like x to the first, so 1 times 300 is 300. And if I lose 1, 1 minus 1 is 0, and x to the 0 is equal to 1. So this just equals to 1 when I subtract 1 from it. So this becomes 300. So that's our derivative, which gives us the slope of the tangent line for this function. But we want to figure out where is the tangent line horizontal. In other words, where is the slope equal to 0? So then we have 0 equals to 6x squared minus 90x plus 300. If I factor out the 6, I'll be left with x squared minus 15x plus 50. And remember, since 6 is a constant, I can divide through by it. So I get 0 is equal to x squared minus 15x plus 50. At this point, I can either solve this by factoring or solve using the quadratic formula. I'm going to choose to factor. So if I multiply 1 times 50, it's going to be 50. The middle term is negative 15. And the two numbers that multiply to be 50 add up to be negative 15 are negative 10 and negative 5. So when I factor this, this is going to become x minus 10 times x minus 5. So I can just put an x over each of these. They don't need to be reduced, so it's x minus 10, x minus 5. So by the zero product property, x equals to 10 and x equals to 5. So at the points x equals 10 and x equals 5, this graph is going to have a horizontal tangent line. We will graph this on Desmos. You can do this if you want to, but we will graph this on Desmos during class. And then we will explore this a little bit further. But feel free to graph this on your own. And when you do, focus on these 2 points, x equals 10 and x equals 5, and see what it looks like. Another example, the equation of the tangent line to the parabola of f of x at the point 5, 63 is. All right, so anytime we have the equation of a tangent line, it's going to be in the form of y equals to mx plus b. So we need to know what is the slope. Okay, so we need to know what is the slope of the tangent line. And remember, slope of the tangent line, that's equal to f prime of x. So first, let's find out what f prime of x is. F prime of x, this is a 2, so if I multiply it with the 2, I get 2 times 2, which is 4. So I get 4x to the first power. I subtract 1. Here, there's an exponent of 1, so 1 times 2 is 2. And then if I subtract a 1 from the x to the first, this gives you x to the 0, which is equal to 1. So this whole thing just equals to 1, and 2 times 1 is 2. The derivative of a constant is 0, so we're going to ignore the 3. So f prime of x is equal to 4x plus 2. But we want the slope of the tangent line at a specific point, at the point x equals 5. So f prime of 5, in other words, the slope of the tangent line when x equals to 5 is going to be 4 times 5 plus 2. The value of x is 5. So f prime of 5 is equal to 22, which means, here's what this means. It means the slope of the tangent line, which is given by f prime of x at x equals 5, is 22. So we know what the slope is. We also know what the point is. The point is 5, 63. So in the equation y equals mx plus b, our y value is 63. Our slope m is equal to 22. The x value is equal to 5, and then plus b. So we got 63 equals to 110 plus b. We subtract 110 from both sides. So if we have 63 minus 110, gives you negative 47. So our equation is y equals to our slope, which is 22, x minus our y-intercept, which is 47. Now, marginal cost and marginal revenue, we will talk about this in class. So feel free to look over this, and then we'll go over these notes in class along with possibly some classwork depending on the time.